Okay, so this is part two. I want to go off script here and let's grab our own data using the Spotify API. I'm going to use Kendrick Lamar for this. The primary reason I'm going to do that is, well, he's got a lot of interesting words, but also, well, we haven't gotten the words yet. But also, he's got really complicated album names with lots of punctuation, so it might address some of the issues some of y'all will run into. I didn't mention in our last video that if we are looking for just an artist's name using the Spotify API, you would type their name in this order. That is, it's not Lamar, comma Kendrick, it's just Kendrick Lamar. It seems to be the way to do it. And when in doubt, you can go to the Spotify. Go to Spotify.com and just see how they're listing an artist's name. All right, so I should have grabbed Lamar. Let me see. View Lamar. And, oh yeah, we're getting all kinds of stuff. So I just wanted to point out while we're here, a lot of this stuff we don't need, but some of it's really interesting. Great. I'm going to go all the way to the end here and point out a few things. So in the last video, we saw key mode, I believe. There's also mode name. That's just the mode, major or minor. Key names, so just splitting those up. We've got album names, track names, etc., etc. So I just wanted to explain what a few of these things are as best as I can. There's explicit column, true or false. There's the duration, that's how long the song is in milliseconds. Okay, so you can do a quick bit of math if you need to change that to normal seconds. Let's see, time signature, that's not going to be applicable for most stuff unless you're looking at interesting music. Let's see. So we've got tempo. I already described Valence in the last video. Liveliness is just what it sounds like. Just keep in mind this is kind of a Spotify invented metric. I'm sorry, that is not liveliness. That's liveness. That's how much it sounds like it's being performed live. Liveliness would be more like, let's see, over here there's energy, danceability. Those are exactly what they seem like. There's also loudness, and let's see, this little section here, so I mentioned liveness, there's also instrumentalness, acousticness. Those are all Spotify measurements that I have found less use for, but they're all documented in Spotify's API documentation. Speechiness is, you know, how much they're talking in the song, so that could be interesting. Is this artist saying more or less? If you combine that with genius analysis and counted the words, I guess you'd be doubling down on that point. So what can we do now that we've got this gigantic Spotify data frame? Well, keep in mind we've got a lot of content in here that we're not interested in. So I'm going to say Lamar and let's say group by album name. Let's see. Yeah, it seems to have worked, but we're not getting, you know, useful stuff here. What we want to do is filter some stuff out. Like if we were to view Lamar here and let's see, I think album name, it's not listed at the front with those other album measurements. It's a little bit further over. Well, I'm having trouble finding it for some reason. But anyways, album name, you know, is, I've already gone through it and there's like multiple versions of some of these. So for instance, I think his last album is called Damn. And there's also a collector's edition version of Damn. So if I want to remove, just get that out of there. Let's make another pipe and let's say filter. And I'm going to put the exclamation point at the front to remove it. So not album name, album. I think this will be useful for a lot of you because again, you're going to get a lot of junk, duplicates, stuff like that. So I'm going to say damn dot. I confirmed the writing of this with punctuation from Spotify. So I'm just trying to match exactly what they did. So there's more. There's also untitled, unmastered. So I'm going to exclude that as well. Overly dedicated. And then Black Panther, colon. Oh, no colon, it's removed that, sorry. It took me a little while to figure out how to get all of these out, so give yourself some time for that. You'll see this one is really odd because it's truncated. Well, we'll get to that in a second. All the punctuation is removed. Inspired by. So that's verbatim how it was written on the Spotify website. It just stops right there. It's kind of weird, huh? But matching what they have on the Spotify website seems to work really well. Okay, let me throw another pipe there so we can finally get back to here. All right, so I'm going to say ggplot. If you have any errors, if you're working along with me, it's almost certainly in the previous line where we had to write all that junk out. So ggplot with the aesthetics defined, where I'm going to say x equals valence, just sticking with the syntax that we used earlier, y equals album underscore name. And I'm going to say fill equals dot dot x dot dot, which is kind of like when we did that fill by count. That'll be blank, so I have to say geom density ridges. I'm going to do gradient, which is kind of cool. All right, we should be able to run that right now. So now we're getting a valence breakdown. Oh, it looks like I missed an album. Yeah, my filtering. My filtering worked a little bit and did not work for this collector's edition. Didn't get Untitled Unmastered. So I just have to fix that. But you see we're getting a nice plot. I have been looking at examples of other people using this. And one thing we can do is add themes. So if you've loaded GG themes, that'll style it a little bit. And let's see, I'm going to add... If we look at it, you see what goes past 0? We just looked up valence, and it's not really supposed to do that. So I think what a density plot tries to do is this is kind of like rounding off, you know. It doesn't have sharp lines. It's all smooth and curved, so this is kind of inaccurate. So if we put a limit on the x-axis and just told it to go from 0 to 1, oh, let me code that right, though. That should improve things a little bit. And one other thing I'm going to say is I don't like the legend. It's just weird. It just has an X with like a color scale. So I'm going to say theme, legend, dot, oops. As if we're going to create a theme, but we're not. We're just going to specify one thing in it. All right, we run all that fun stuff, and we get this. And that looks a little better. Perhaps now is a good time to point out all of the background noise going on. My 3 kids are going insane in the hallway. My dog finally settled down. That was that like tap dancing noise you heard in the background. This is nails on our wood floor, but now he's sleeping. Who knows what's next? Okay, so I thought that looked pretty nice. Obviously, I'd want to find where I messed up this filtering. I had a version of this that worked, so I mean, that's doable. But I'd like it to just be, in case it's not clear, his 4 major studio albums. And I confirm that by going to Google or Wikipedia and looking at the studio albums. So that's going to prevent any duplicates. Really good idea if you are using this. Okay, so that was a lot of code. I was going to duplicate that code, but unfortunately it didn't work, you know, perfectly. But let me do this. I'm going to take these first 3 lines or so. All right, grab those and paste them down here and say I'm going to take Lamar and I'm going to move this group by album name down here. So now we're saying Lamar and filter. So what I was saying is didn't work is that filtering didn't work perfectly, but we're still getting some stuff. And then I'm going to group it by album name. And then here, let me get rid of this. So the same start, but then I want to say summarize, written in New Zealand style. And I want to summarize the mean of the valence. Does that make sense? And then I'm going to arrange in descending order. And this is a little weird. This took me a little coding around, but we have to put quotes around this because it's now like a column, right? So we have to say, or not quotes, the backticks. Mean valence. And that, valence with the lower V. That took me about a million years to figure out, and then I'm going to cable it again. Yeah, okay. I got something wrong there. I think this backtick needs to go there. And now I got 2 backticks, all right? So I guess I'm demonstrating the types of things that can go wrong. All right, arrange descending mean, valence. Let me get one of those backticks on. Nope, I still got something wrong. Let's see. Summarize mean, valence, and arrange, quote, descending, mean, valence. You know what, I think I'm missing another one right here. Woo! All right. Fun with coding. Okay, so again, I got 2 albums in there that I don't want, but it looks like Untitled Unmastered has a period at the end of it. So, dot. Yep, that got it. And it looks like Damn Collector's Edition does too at the end here. So I guess that was my error. There we go. So coming back up here, we can say put a period here, Untitled, was it Untitled Unmastered period? Yeah. Just to go back to our plot from earlier, there's the 4 albums. Much better. Well, I'm glad we figured that out. Anyways, when we run this, we're going to get a breakdown of the mean, right? The average, I guess, of the valence per album. So you can get a sense of what is positive and what is negative. Now, what can we do with that? Well, the most interesting thing to do with it would be to combine it with lyrics. Now, to combine it with lyrics, we're going to have to grab some content from the Genius API. So I'm going to say library Genius. I am consistent in my typos. I don't know if that's useful. So this is already a long video. I'm just going to do this on 1 album instead of all 4 of those albums. So, I mean, you'll get an idea of what's going on. I'm going to say artist equals Kendrick Lamar. Album equals, quote, Damn, and I had to look this up on Genius, and they remove the periods in Kendrick Lamar's album names. They're just gone. Remember, this process takes a little while, so that's why we're waiting for the stop sign. Let's see. We are going to need, I'm going to say library tidy text. I'm not going to run that yet because I'm still loading. I'm going to say library, ooh, that's a new typo. Library text data. Remember, we need that to access some of our sentiment lexicons. All right, man, that is still running. Okay, there we go. It's just finished. So let me load tidy text, load text data, and let's view. Damn. All right. So track title, track end. We don't care about line. We're not caring about here in the lyric. So that worked just fine. Yeah, I've got multiple track names. Those are the track names of that album. They're all written that way with the periods and the capitals. So again, I'm using him as a demo because of the uniqueness of the writing style that demonstrates a lot of problems y'all might run into. So let's say damn and unnest tokens. So we're going to say word lyric. Right? Let's make sure that's working. That's working. And so let's go ahead and anti-join our stop words. Also seems to be working just fine. So I will pop in another line that says inner join get sentiments. Let's do Bing because I want to create some visualizations using Bing. We'll also use Aphin really briefly. All right, again, that seems to be working, so let me pop it equal to damn words. Okay. So now we got damn words, and I'm going to take that. And let's start by doing a count. We're going to count word. And often here we just say sort equals true. And if we do that, we're going to lose the sentiment column, right? It's just word and n. So I'm going to say word, comma, sentiment. And really, I think what we're telling dplyr to do is do a count of word and secondarily do a count of sentiment. But more importantly, for our purposes, it keeps the sentiment column. All right. A lot of bad words in here. I guess muting doesn't work in this case, so just have to fight through. Okay, so we counted, and we're getting. We know what to do with this. We've played around with it before. I was playing around with these specific results, and there's a lot of words. It's a wordy album, so I decided I'm going to do a filter where n is greater than 2. In other words, I only want to look at the words that he says at least 2 times, and that's not the and of. Remember, we removed the stop words, so this is other words. And then I'm going to go ahead and plot it. Let's see, AES. I have already run this, so I know we want to reorder the word based on n. I'm probably going to have an error here with my parentheses. So then n. I'm going to say fill equals sentiment, so we can get some nice color in there. So I should have 2. Yeah, okay. And geom call. And let's coord flip. And let me just throw one more line in, which is a facet wrap, which we're going to do along the lines of sentiment. And I'm going to say scales equal free y, so they adjust themselves accordingly. Don't put themselves in the same plot with blanks, basically. Let's see if that worked. Okay, that worked. So we got our list of negative and positive words, and you can see the n. I mean, the scale's the same. That's what all that code did. We might have wanted to cut it off a little earlier. That is, with the filter with the n maybe greater, get fewer words. So we could always pop it back and say just words that he said 5 times, or something like that. We'll get another plot with fewer words. So however you want to cut it. If you're doing this on a multi-album basis, you probably want that n is greater than to be the same. Let me show you one other way that we could visualize this. Oops. I'll show you 2 other ways, actually. This one is also kind of familiar, but let's say damn words and can't. I'm actually going to write basically the same word we wrote, or line we wrote earlier. Count word, sentiment, sort equals true. So that's this line that's the same. And arrange in descending order of n. Now that I think about that with count and sort, that is unnecessary. That last line. All right, so we'll cut it off at 10, just so we don't get too many words. And I will plot it. Let's say AES, reorder, word n, and then probably comma n. Need both of those, and geom call. Hope this doesn't create the exact same thing. That'd be kind of embarrassing. And coord flip. Yeah, so here they are on the same axis. That might have been head 10 might have been too severe for combining these. I like the first plot more, but just showing you a different way to take a look at it. All right, so how can we relate something like this to the density plot we got from Spotify? Well, that's pretty tough to do. So can we create a density plot of our sentiment? Well, yeah, and it took a little screwing around, but it's certainly doable. So I'm going to say this is going to be a damn density plot. So I'm going to take damn words, which we made a little while ago. We've been playing around with, and I'm going to say count word sentiment sort equals true. Starting to think maybe I should have created a variable for that step because I keep writing it. And well, gosh, this is all just the same. Arrange descending order of n, which again I don't think is necessary, and head, but it's not going to hurt anything. Head 10 and ggplot. So here's the new part. I guess I should have copied and pasted. We're going to say AES x equals n, y equals as dot factor sentiment, and that's going to be a geom density, ridges. It took me a while to get that to work. I kept having to swap these values. Also, you know, this is going to work with density plots are based on numeric values. So it's not going to plot like your words, right? So what can we see here? There are more positive than negative words. There are more negative than positive words. There seems to be, for positive words, a kind of like digression in the middle. Well, you can analyze this however you want, but that's kind of an interesting sentiment view. Let's see, what else can we do with this? Well, let's create something similar. I'm going to go back to Lamar. Remember, this is the one from Spotify. So I believe if we wanted to just create a plot for this Damn album, right? So we could compare these two things. We could do that. Okay, so I'm going to say Lamar and group by album name. You know, it's probably not necessary either now that I look at it. And we're going to filter album name includes Damn, period. And for fun, let's just make sure that's giving us results rather than errors. Hee-haw. So let me pipe that. So we're going to ggplot AES. In this case, it'll be x equals valence. And let's see, y is going to be album name. There's only one album. Fill equals ... x ... And you can see I'm not straying far from the plot we got working earlier. Ridges, gradient. I'll just finish writing it myself, thank you. Okay, let's take a look at that. So this is just the valence from just the album Damn, and it's really middling. So if we compare that to our previous plot, you know, it seemed like there was a dip in the middle for the positivity. Now, obviously, these are different scales, right? So I can look at valence and say, oh, it goes from 0 to 1. You know, our sentiment doesn't go from 0 to 1 if we take a look at it. We're not even measuring it on that scale. We're just measuring the n, right? So it's not that exact. Y'all might remember the AFIN scale works a little better in terms of numeric values. So I played around with that too. So if we said, let's see, did I create something with Damn? Yeah, it looks like I did. So I'll say, let's take this record and, I'm sorry, this is just the lyrics, and let's unnest tokens, word, lyric. I don't remember earlier in this tutorial creating this variable Damn, but all I would, this would do it. You'd say Lamar and filter album name includes Damn, and then set that equal to Damn. I don't know, just go ahead and do that. Apologies if I did do this and I somehow forgot. Filter album name equals Damn, and we'd set that equal to Damn. Okay. So assuming we've done that, we can unnest our tokens, word lyric, and let's anti-join our stop words. Now we did do all this stuff before, but we merged it with a different sentiment lexicon. So I'm going to do inner join get sentiments, and this time we'll do AFIN. Make sure that's running. Seems to be fine. A lot of negative words there. So I'll set that equal to Damn AFIN. Okay, so now we've got Damn underscore AFIN to play around with. And if we wanted to look at, you know, $ value is, I believe what it's going to give us for, again, there's all the values for the words. So we could say mean. So that is the mean score in AFIN. In other words, this is a slightly negative album by average. Okay, so that's a quick lyrics and valence comparison. While I've got you, let me quickly show you some fun stuff we can do with keys, just as an example of how you can play around with all this stuff. I'd encourage you to play around with tempo, danceability, depends on what you're doing, but I'm going to do count, key mode, sort equals true, and let's ggplot it. AES, reorder, key, mode, N, and all right, that looks pretty right, and geom call, and chord flip, but correct. You're not normally going to get results like this. So C sharp major, I mean, that's just crazy. He is using that like almost 3 times as much as, or maybe 4, a lot more than other keys. That's interesting. That's just on that one album. No, it's not, is it? That's all of his albums. Okay, sorry, that's just Lamar. So that's it, right? If we did view Lamar, it would be all of his albums. So I didn't even filter out some of them. So I bet there's a lot of duplications. In other words, let's say he had a hit song and it was remastered 6 times. There could be a whole album remasterings. That's where this is an example, I think, where you'd get that issue. So how would we fix that? Well, we'd probably want to go back to where we filtered out all those albums that weren't what we want. Wow, it's been a while. All right. So this crazy long line, let me grab that and we'll just see if this works. Okay, so when we filter all that stuff out and we're just looking at those 4 albums, C sharp major, still killing it. The number's way lower though. We're at, what, 50 something? Still almost twice as much. Just more accurate. Okay, so that's a key mode. Let's see. I think we can also do, like when we look at that, it's interesting. If we wanted to compare this to like sentiment, which you can't do directly. But I think most people agree minor chords are a little bit sadder sounding than major chords. Well, this is showing us the key, but not just the mode. So if we want to do that, we could. I'm going to grab this whole thing, copy it, paste it, and if I'm not mistaken, just any place we've got key mode, we're going to change it to mode name in snake case here. So that would be when we're doing the count, and then when we are doing the ggplot. Mode name. This is not an exciting graph, but you can see that he uses major slightly more than the minor mode. So not a major statistical difference compared to that, what was it, that C sharp? C sharp major, man, that is really popular. Okay, so again, the other measures that you can look at are loudness, duration, time signature, tempo, energy, danceability. And if you're going to get into the more Spotify-ish measures, like liveliness, liveness, instrumentalness, acousticness, and speechiness, you definitely want to explain what those are, because most people haven't heard of them. All right, I hope that helps you get started with the Spotify API in R. Have fun out there.